This is a video for an owner who needs a little visual assistance setting up his choke mechanism. So I'm going to show the 4 different adjustments that you can make to the choke mechanism. The first adjustment is the length of time that the choke mechanism will take to complete its warm-up cycle, the overall length of time. The second adjustment is how fast the engine will rev above the normal idle speed during the warm-up cycle, the number of RPMs that the engine will be spinning during the warm-up cycle. The third adjustment is a relationship between those first two. How much time the engine will spend revving above the normal idle speed relative to the amount of time that it is taking the choke mechanism to complete its warm-up. And then the fourth adjustment is the amount of initial choke plate action, how far the choke plate will be cracked open at the beginning of the choke mechanism's warm-up cycle, kind of the starting point from which the choke plate will then ultimately open all the way. Before I show you the adjustments of the choke mechanism, let me just give kind of a thumbnail description of what the choke mechanism is and what it does. Pretty much all carbureted fuel delivery systems, lawn mowers, chainsaws, weed eaters, and carbureted automobiles have a choke mechanism to assist a cold engine to run properly until it has warmed up and reached its normal operating temperature. Assist the engine to start and then run until the engine has warmed up. And the way it works on a 2100, when you very first start the engine, there's this plate, the choke plate, that is fully closed. And as soon as the engine starts, the choke plate needs to crack open. The engine can't draw air through a closed choke plate, so the choke plate will crack open to allow some air to be pulled through the carburetor, but it is still providing a restriction to the airflow, which will cause a bigger pressure differential in the venturis, which will cause more air to be pulled through the venturi cluster than would otherwise be pulled relative to however far the throttle plates are open. It enriches the fuel mixture. And then as the choke mechanism continues to warm up, it will open the choke plate further and further and further until it ultimately ends up fully open, providing no restriction. And at that point, the choke mechanism has completed its warm-up cycle, and the engine will be metering fuel as it does when fully warmed up. The second thing that the choke mechanism will do is it will crack open the throttle plates. This is where your throttle cable attaches. And so it will slightly move the throttle linkage, slightly open the throttle plates, just as if you were stepping just a little bit on the accelerator pedal. And one of the adjustments that we'll make is how much these throttle plates will be cracked open. The further they're cracked open, the more RPMs you'll be pulling, the faster the idle will be during the warm-up cycle. And the less they're cracked open, the slower the engine will spin, the lower your RPMs will be. And by the end of the choke mechanism's warm-up cycle, the throttle plates will be fully closed at their warm engine settings. So what we're going to be adjusting is the operation of this plate, the choke plate, which moves according to the length of time that the choke mechanism is operating, doing its warm-up cycle. It can open very slowly, or it can open much more quickly. And then we'll be looking at fast idle. How many RPMs, how fast the engine will be revving while the choke mechanism is warming up, ultimately going back to its fully closed warm choke setting. This is what's going on behind that plastic cap. This is the choke mechanism itself. And as this forked fitting moves, this is its range of motion from fully closed to fully open. You can see that it operates the choke plate from fully closed to fully open. And it also moves, you can see down there, a metal fitting moving. It's called the fast idle cam. And we'll get to that. But you could imagine having a cable attached to this, running to your dashboard. And you'd pull that cable out, and it would close the choke, and you could imagine pushing the cable in, and it would open the choke. And you could pick intermediate settings between fully closed and fully open. And that's how manual chokes worked before they went to automatic chokes. This is an automatic choke. They weren't shaped exactly like this, but it was the same principle. You would push and pull a cable to do what we do automatically. And what operates our automatic choke is this plastic cap. Some people call it a thermostat. I call it a choke cap. This is the back side of it. It's ordinarily mounted like this. And that forked fitting fits right there. So as this spring expands and contracts, it causes this fitting to move through its range of motion. When the spring is cold and fully contracted, it's over here, and when the spring has expanded, it has moved it over here. So that is what's going on behind this plastic cap. The very first adjustment that I'm going to show you is how long it takes the choke to go through its warm-up cycle. How long it takes the choke to move that forked fitting from here to here. From fully closed, fully cold, to fully warmed up, fully open. And remember that forked fitting is being moved by this coiled spring. So you could imagine that if I was to wind the spring tighter, if I was to put more tension on this spring, it would have to expand further to move that forked fitting from there to there. And conversely, if I was to unwind this spring, if I was to take tension off of this spring, it would not have to expand as much to move that forked fitting from there to there. So that is how you adjust the length of time that it takes the choke to go from fully cold to fully warmed up, is you tension and untension this spring. And you can see that as I increase tension on the spring, that it is closing the choke plate and moving that forked fitting over there. And as I unwind the spring, it's moved that forked fitting over here and open the choke plate. Now, the way I have it currently set, the spring inside this cap is cold. Okay? It will never move any further in this direction. It will only expand and move in this direction. But the forked fitting is already over here. So the way I have this choke cap set currently, the choke will never operate. I have too little tension on that spring. Conversely, you could imagine that if I just kept tightening and kept tightening and kept tightening, that I would eventually reach a point where the spring would never expand enough to move that forked fitting from there to there. There would be too much tension on that spring. It would never be able to expand enough. So what you want to do is set an initial choke setting that allows the choke plate to close when the spring is cold, and then fine tune it. If it's still warming up too quickly, if the choke is not taking long enough time to move that forked fitting, you can rotate the cap further. As long as the choke eventually opens fully, you know that you have not reached the point where the spring cannot expand anymore. And so you could increase the time even further. And if you discover that you've put too much time on it, it's taking too long for the choke to warm up, you can rotate it back and take tension off the spring. And once you have a length of time that you're happy with, you tighten these 3 screws. These are what hold this ring, which holds the choke cap tight, and it will not change the setting that you have selected. Let me explain what causes this spring to heat up and expand and operate the choke. This is an electric choke cap. It uses electricity. Inside this cap is a heating element, and it uses electricity to generate the heat that will then cause the spring to expand. In fact, this is what the heating element looks like. And the way the cap is constructed, this is the terminal where your 12 volts goes in. And then you have a spring that keeps everything tight and conducts the electricity to the element. I'm going to take the spring out because it's too springy. And you have the element. And then resting against the element is a hot plate that has the spring that's going to operate the choke. And then it's grounded through these 2 tabs through the ring that holds the choke wherever you set it, choke cap wherever you set it, through the choke housing, through the body of the carburetor, through the intake manifold, and ultimately to your block ground. Now, like any electrically resistant device, this element will eventually burn out, just like a oven element or a hot water heater element or any other electrically resistant element. And the way you test it is just like you would test any other element. You just pass resistance through it. Now this is a brand new choke cap, so it's got very, very little resistance because its heating element has got no use. This choke cap here is a little bit older, so it's got a little bit more resistance, 42 ohms, but it's still good. There's another old cap. This one got about 36 ohms. Still good. But they do eventually wear out. Like this poor old cap here. He does not conduct electricity anymore. So he would need to be replaced. And they don't cost much. They're $15 to $30, and they're all over the internet. But that being said, if you measure resistance through the choke cap and you're not getting any kind of a measurement, before you assume that the choke cap is bad, take a measurement directly to the hot plate. Because if you get a good reading to the hot plate but not to these terminals, then the culprit is going to be these rivets. And just like a DeLorean taillight board, these rivets do loosen up and don't make good contact. So if you have a choke cap that is not conducting electricity to these tabs on the side, but is conducting it to the hot plate, definitely flatten out the rivets, just like you're trying to tighten up a DeLorean taillight board. Because the choke cap is still good, it's just the rivets went bad. But if you don't get a good reading even to the hot plate, then the element inside has burned out and the cap needs to be replaced. So that is how you adjust the choke cap. You rotate it counterclockwise, which will increase tension on the spring inside, which means the spring will have to expand more. It'll take longer for it to heat up enough to move that forked bracket through its range of motion. Or you rotate the cap clockwise, which will decrease tension on the spring inside, which will decrease the amount it needs to expand to move that forked bracket. Longer warm-up, shorter warm-up. The next adjustment I'm going to show you is this screw right here. This is the fast idle screw. And what this screw does is it pushes on a bracket that is attached to the end of the throttle plate shaft, and that will determine how far the throttle plates are cracked open as the choke goes through its warm-up cycle. In fact, I've got a carburetor here with the choke housing removed so you can see it a little more clearly. This here is the fast idle screw, and you'll notice that the bracket that it's in is attached to the end of the throttle plate shaft. So moving the screw in this direction opens the throttle plates more. Moving the screw in that direction opens the throttle plates less, increasing and decreasing the RPM. And you'll notice the screw is riding on this cam. This cam rotates. It is attached to the choke mechanism with a rod that goes right there. So as the choke is going through its range of motion, it is also moving this cam. When the choke is closed at the beginning of the warm-up cycle, it's about like that. And at the end of the warm-up cycle, it is rotated like that. In fact, you can see that when the choke is fully warmed up, the fast idle screw is like that. It's not even on the cam, not even touching it. But now, the cam cannot rotate back. That is why you step on the accelerator pedal when you're very first starting a carbureted engine. When you step on the accelerator pedal, it moves the fast idle screw out of the way, and that allows the fast idle cam to rotate. back to its cold choke setting. And then you're ready to repeat the cycle all over again. Start the engine, the choke warms up, throttle plates are fully closed, but now the fast idle cam is preventing the choke from rotating back to its cold choke settings. So the next day, you step on the accelerator pedal, it moves the fast idle screw out of the way, the cam rotates back, and the choke repeats its cycle all over again. Let me actually turn that screw so you can see it moving the throttle plates. There's the fast idle screw. Now watch the throttle plates as I turn the fast idle screw in. You see it cracking the throttle plates open further and further and further. Conversely, watch as I turn the screw out. You see it closing the throttle plates. And it doesn't take a whole lot of turning of the screw. I'd say one full revolution is close to 400 or 500 RPM. So just a couple of revolutions of this screw is like 1,000 RPM. So it doesn't take a whole lot of adjusting. Just a little bit in or out will raise or lower the RPMs during the choke warm-up cycle. And after you've set it to what you want, the spring that's under the head of the screw has tension, and it will prevent it from rotating from where you've set it. So that's your second adjustment. The fast idle screw controlling how many RPMs the engine will rev at during the choke warm-up cycle. Okay, I've showed you the choke cap, tensioning the spring inside the choke cap. That will adjust how long it takes the choke mechanism to go through its warm-up cycle. I've showed you the fast idle screw. This will determine how many RPMs the engine spins at during the choke warm-up cycle. Now let me show you what this screw does. This screw adjusts the relationship between those first two adjustments that I just showed you. Okay. Here is the fast idle cam that the fast idle screw rides against. And here's the rod that connects the fast idle cam to the choke mechanism. And then here's the back side of the choke mechanism. And you'll notice there's not a direct connection between the two. The relationship between fast idle cam and the choke mechanism is adjustable with this screw. I can raise and lower this plastic fitting relative to the choke mechanism. See, this plastic fitting moves independently of the choke mechanism. Here's the forked end that the spring is going into, and this is a direct connection to the backside here. But by turning the screw in and out, I can raise and lower this plastic fitting, which is where the rod that then runs down to the fast idle cam attaches. So if I raise this plastic fitting higher, it will lift this connection point higher, Now the fast idle screw is positioned very high on the fast idle cam, which means that it has further to travel before fast idle kicks off. It hasn't changed the RPMs. Okay, the RPMs are set by how far the screw is pushing off against the cam. So the RPMs haven't changed. What has changed is how long those RPMs are going to be in effect relative to the overall movement of the choke mechanism. Conversely, I can turn this screw out, which will lower this plastic fitting down relative to the choke mechanism. It'll position the fast idle cam lower. So now the fast idle cam won't have as far to travel before fast idle kicks off. RPMs will remain the same. What I'm changing is how long those RPMs will be in effect relative to the overall warm-up time of the choke mechanism. If I want to have longer fast idle relative to however long I've tensioned that spring, I will adjust the screw to raise this plastic fitting up. If I want shorter fast idle relative to whatever time I've set by tensioning that spring, I will turn the screw out and drop that plastic fitting lower. And once I've got my length of time of fast idle where I want it, it's a tight fit for this screw into this plastic fitting. Friction alone will hold the screw wherever I put it. The last thing I'm going to show you is the choke pull-off. This is the choke pull-off on a 2150. It's an external device mounted to the rear of the carburetor. And then this is the choke pull-off on a 2100. It is integrated into the top casting. They're two different designs, but they both operate the same way, and they're both adjusted the same way. I'm actually going to show you the adjustment on the 2150 because it has an external hose here, and that will allow me to attach a vacuum pump to emulate manifold vacuum. You know, there's no hose on a 2100. The vacuum passages are all built in. It's harder to put a vacuum pump on it. That's the vacuum passage right there. Runs up the back of the carburetor there and to the vacuum chamber where the diaphragm is. And that's where it accesses the Venturi bore. And the 2150, there's the hose, and the vacuum is accessed right there. But pull the hose off and attach a vacuum pump here. And the way the choke pull-off works is when you start the engine, manifold vacuum cracks open the choke plate so the engine can breathe. The engine can't run with the choke plate all the way closed. Now you can adjust how far that choke plate opens and closes when the engine starts. And the way you do that is with this screw right here. Okay. If you turn this screw out, it will allow the choke plate to open further. In fact, I can adjust it to where it's basically all the way open. So now, the way I have it adjusted, when I go to start the engine, it basically cracks the choke plate all the way open. Conversely, I can turn the screw in and it will reduce how far the choke plate cracks open. And in fact, I can turn
the screw so far that the choke plate basically doesn't open at all. So now I go to start the engine, and the choke plate isn't opening at all. And it won't run like that. So let me back the screw out here a little bit. I just eyeball this usually, test drive it, see how it test drives. That's pretty good there. So now I go to start the engine, and cracks open the choke plate. A 2100, you adjust the choke pull off the same way. That's the screw that adjusts how far the diaphragm can open when you start the engine. Just like that screw there. So if you want the choke plate to open further, you're working from underneath, but you let that screw down. If you want it to not open as far, you turn it up. Let me say one last thing about the choke pull-off here. There is some misinformation on YouTube. If you go to YouTube and type in Motorcraft 2100 choke, the very first video that comes up is from a fella named Mike, who has a business called Mike's Carburetor Parts, which is a perfectly fine business. I've bought stuff from him myself. But he has a video where he's explaining the operation of the 2100 series choke, and it is basically an accurate video. It's not as detailed as this video, but it is accurate up until the point where he discusses the choke pull-off. He uses a 2100 in his video, just like this. And he correctly points out that manifold vacuum pulls down the diaphragm that cracks open the choke plate. And he also correctly points out that when you open the throttle plates, manifold vacuum drops and this diaphragm relaxes, which would ordinarily reclose the choke plate. He describes it as you're driving around and the choke plate is doing this. That is incorrect. The engine would not run like that. If you were idling like that and then you then open the throttle plates and the choke plate closed, the engine would cough and sputter and probably die. The choke plate cannot reclose once the engine has started. And the way it does that, there is this tab right here that will manually open the choke plate irrespective of the choke pull-off diaphragm. As you open the throttle plates, the choke plate is mechanically cracked open even without any vacuum pulling down on the choke pull-off diaphragm. So when you're driving down the street, this is what it looks like. If you're at a stoplight, the choke plate is cracked open from manifold vacuum. Then you open the throttle plates, which causes manifold vacuum to drop, but that mechanical connection is keeping them cracked open. And then you get to the next stoplight. As you close the throttle plates, manifold vacuum will reopen the choke pull-off diaphragm, so it stays open as you're driving, and then the choke mechanism itself gradually opens the choke plate the rest of the way.
So those are the 4 adjustments that govern the operation of the choke mechanism. First, how long it takes the choke mechanism to complete its warm-up cycle. That's adjusted by tensioning and detensioning the spring inside the choke cap. Second, how much fast idle, how many RPMs the engine will spin during the warm-up cycle. That's adjusted by how far the fast idle screw is pushing off against the fast idle cam. Third, the relationship between those two. How much fast idle cam action you get relative to overall choke mechanism action. Basically, the amount of time it takes the fast idle cam to move relative to the amount of time it takes the choke mechanism itself to move. And you adjust that by raising and lowering this plastic fitting that the connecting rod to the fast idle cam is attached to. And then lastly, choke pull-off. How far the choke plate is cracked open at the beginning of the choke warm-up cycle, from which the choke mechanism will open the choke plate the rest of the way. So those are the 4 adjustments that govern the operation of your choke mechanism.